Okay, class. For this video session, we will discuss heaps. Okay. Okay. So a heap is a special tree-based data structure in which the tree is a complete binary tree. So we already discussed a complete binary tree, right? And generally, heaps can be of two types. There's a max heap and a min heap. So in a max heap, the key present at the root node must be the greatest among the keys present at all of its children. The same property must be recursively true for all those subtrees in the binary tree. Uh, uh, in the min heap, it's the opposite. The key present at the root node must be the minimum among the keys present at all its child nodes. And that property must be the same also and apply recursively for all the subtrees in the binary tree. So here's an example of a heap data structure. This is a min heap, where if you look at the root node, the value here, the key value is 10. It's the minimum among all, and for each node here, it's the minimum among the key values of all its child nodes. Okay, the max heap, the root node will have the maximum value. Okay, and recursively that is also true. Okay? So the question is, what if we want to insert a new node into the heap? Okay, so there's a process called heapify up, and the idea here is that once you insert it, you maintain the heap property. Okay, so here's an example. We want to insert 42, and since we want to insert it at the leftmost leaf node as the leftmost leaf node, and we compare if it is since this is a max heap here, we have to compare it successively with the values on the of the parent nodes. So in this case, for example, 42, is it greater than or less than 27? It's greater than, so it has to go up. Compare it with the next number, 35, it's greater than, so you replace it, and now compare it with 45. Since it's less than, then it stays there. Okay. Okay. So how about the heap deletion? So to maintain the heap property, the process is called heapify down. So when you delete something, you want to maintain the heap property. So in this case, it's a max heap, and you want to delete um, the value. Okay, so deletion can only be made at the root because that is the only way to ensure that we can maintain the heap property efficiently. Okay, so this only it's only allowed at the root node. Okay, and you will see this later on when uh, we will show how heaps are used for priority queues. Okay, so when you delete, for example, 42, okay, the question is which value do we put there? Okay, so what we do initially is that when we delete that root node, we we replace it with the value of the leaf node, which is the last element in the heap. Okay, so 27 goes there, and then once it's there, then we do a heapify down. So we compare it recursively to the subtrees and determine its proper location in the heap. Okay. So as you can see here in this example, 27 is less than 42. So we put 27 down. 27 is less than 35. So we replace it there, exchange it, and then finally, since 27 is greater than uh, okay, 19, so it maintains the value there. Okay. Okay, so let's look. By the way, both the heap deletion and heap insertion take O log of n time complexity. So if you look at the heap implementation for in Python, the heap data structure is mainly used to represent or implement a priority queue. And in Python, this is available as the heap queue module. So in Python, the implementation is a mean heap, okay? So which means that when you want to pop a value, the smallest heap element is returned or popped out from the queue. That's why it's called a heap queue. And since it's a heap data structure, then every time you push elements, you insert, meaning, or when you delete using the pop function, the heap structure is maintained as we explained in the previous animation. Okay, so the heap 0 element also returns the smallest element each time. Okay, right. So let's see the various operations on the heap. So heapify is used to is the function used to convert the list or iterable into a heap data structure such that it will be in heap order. And you can insert by using heap push, okay? And you can remove and return the smallest element, meaning since it's a mean heap implementation, using the heap pop, okay? There are also two variations of in the case wherein you want to combine both push and pop operations into one statement. Because you might want to push first and then a new value and then pop from the heap, or the other way around. You can pop first whatever is the smallest value and then push a new value. So both functions are implemented in Python. So there's a heap push pop, okay, and then there's a heap replace, okay. So the heap push pop is it pushes first and performs the heapify, the heapify up to maintain the heap structure, and then it pops, so it performs the heapify down. However, the heap replace performs a pop first before inserting. Okay, so it depends on what you want to implement. Okay, and there is also two other functions: n largest and n smallest. So these functions will return the k largest or smallest elements from the list specified. Okay. So here are some examples which you can run and examine them, try them out, and play around with them.